Hello, this is a video of grinding this little Schaublin Tailstock Quill. Just warming the bearings up on the grinder. I don't know if that finish is coming through very well or in focus, but I've had this, I ground it down and then I've had it hard chromed. And we'll now grind it down to the finished diameter. I'm hoping for 2 to 3/10 clearance with the bore and the tailstock that I lap. So the first thing I do, this top table pivots about this axis. So the first thing I do, give you a view of the whole operation here, is I bring the wheel and touch the wheel right at the pivot point. Then I bring the wheel down and I touch here, and I compare where I am on the infeed, and then tweak with these screws here, this pivot table, until I get the exact same diameter. And that's it's a bit of a fidgety process, but the plater allows lots of allowance for grinding. So I'll tweak that until I'm getting a tenth. The same reading within a tenth over the diameter, and then I've got a tenths indicator mounted behind that I'll use to come up to the final diameter. Okay, there you can hear it. That's at 44 on the dial. So I'll back out. In here, as I come up to getting close to 45, we'll see where we're at. It's crucial that you use flood coolant for this. It washes away the stuff, keeps the wheel clean, and stops any heat buildup that might hurt the chrome. Okay, so I'm quite a bit off, about 5 thou, believe it or not, which could just be a difference in the plating thickness. So I think what I'll do is I'll take a cut, and measure diameters, and we'll go from there. Yeah, I don't know if I have to dress that wheel more, but I was getting a better finish on this hard chrome with the Norton wheel than I am this KBC CBN wheel. I don't know if it's the wheel or the operator. I suspect the operator, but I've only got one chance on this thing. So I might switch back. Okay, I've dressed this Norton wheel. It's a 60 grit wheel. Really a good wheel. I get great results with this. And you know, CBN is obviously a fantastic thing. I just need to learn what I'm doing wrong. I think it's that I didn't dress it enough, but I've only got one go on this quill, so this isn't the one to spend time learning at, and I believe I can get a really good finish with this wheel. So we'll do a bit of grinding. And see what we get. So end to end, I was 6/10 different. So I've tweaked the pivot table screws a bit. I'm still working away at this. I've got about 15 thou to remove, so I have lots of runway to tweak things until I get the right diameter. This is a bore gauge. That's graduated in thousandths of a millimeter. So hopefully this tailstock quill was lapped, and it's so here if I do a sweep, I'm there 91 on the dial, 95 on 94, 95 on the dial, 95 on the dial, 91. If I go to a different position, 90, 95, 95. So what I'm going to do, that's done with a hand lap. I got that to within 5 microns, which I think it's pretty good. Really, most of it is within a couple of microns. Most of it is up around 94, 95. It's only at this end. Most of the bore is 93, 94, 95. It's just right at the end here where it gets a little bigger. The middle of the bore is a little bigger. I mean, we're talking microns, so it's a very, very small amount. I want to have 3/10 clearance. So if I size things to just be under the smallest point, I'll be well within my 3/10 clearance everywhere. So I'm going to call that the smallest there is at of course it's very round because it was lapped. Hello! Continued work on the Schaublin 70 project. I redid the tailstock quill. I wasn't happy with the finish I got the first go around, so I ground the hard chrome off. I took it back to the platers and I got it reground, and I've ground it to size now. I'm quite happy with the results. Just to give you a little bit of a sense of it, this is the bottom scraped parallel to the quill and the bore. You can see there, this is a tense indicator. Hopefully that needle's in focus. And then end to end here, we're within a, maybe move that for a better view. We're pretty much within a 1/10 there. So pretty pleased with that. Right. And then the other thing is just to kind of give you a sense of the fit of the bore. This is unclamped, and you can see that the quill moves freely. There's just the slightest bit of oil on it, but it's just not falling out. So that's the type of fit that I wanted, and that's the type of fit that I was able to achieve. So it's definitely free to move, but with just a little bit of a film of oil, it doesn't drop out. So that was my compressor that kicked in. Sorry about that. The end, I made this mandrel here, and it is a very light press fit in the collet end of the bore. You can see there's a keyway there. That was to catch the pin in the quill. So with this pressed into the bore, this was my between centers for grinding. I was able to get, I think, the quill inside. I was able to get the inside of the quill concentric with the O. I want to grind the inside of the quill, and to do that I'm going to use this nice little Swiss Hauger lathe. And I'm just setting up the slide rest to be at 15 degrees. And the way to do this accurately, of course, is with gauge blocks and a sine bar. So I've rigged this up on the back side of the slide rest, and there's the gauge block stack for 15 degrees. And I've pretty much got this. Of course, it's tense indicator, so you touch the alignment device here and it moves it. But once I get it moving, if that needle doesn't appreciably go from, isn't trending up or down, you see there it's at about 0.6. And it really stays at 0.6 if I keep kind of a steady motion across there. I think that's pretty well aligned. I've been at this for a little while without the video on, so I didn't just luck out and get it that way. I've been tapping it into position. But I think I'll put a little bit of a snug on these, on the locking screw here. Just double check that I haven't moved it by locking it. But yeah, that's pretty much the air compressor that popped on a second ago. Anyways, getting really close. Just make sure this is in focus. This is at the outboard end now. You can see that's within 1/10, which it's taken a lot to get there. And don't breathe on it. And if we go to the chuck end, that's maybe 1.5, maybe 2. This is where not having the graduations can be to some advantage, and that you can convince yourself it's anything you want it to be. We'll risk danger and give this the tiniest of tweaks. That's solidly within 1/10 there. See what we've done at this end. And it's about 2/10. Affecting things. I did try to align the probe with the direction of rotation, but anyways, you can see there that's within 1/10. That's really good. And here that is within 1/10. So I would call that quill perfectly aligned. Got to be happy with that. And now I'm going to set up under if you were machining the end of it with a single point tool, you might not want to have that sticking out, but I'm going to be taking the lightest of grind, so I'm not too worried about overhang. And I intentionally left quite a bit sticking out because I wanted to have enough to get it into 2 planes, so that I wasn't putting the taper in the end of this unit, with the shaft like that or like that, etc. When you're working with the taper, it's very important that the cutting tool, in this case a small grinding point, is at the same height as the work. So one way to do this is I've got a drop indicator or dial indicator here that I've zeroed out on the high point of the work. This is 0.791, and then I take this and I go over to here The difference, I'm looking for half the difference, which is 83.5 thou. So, just gonna set that again, because I've been moving things around here. Sweep it, find the high spot. Okay, I had to redo that. I was trying to orient the dial so that both of us could see it, but couldn't. So I got it set. Now I've zeroed it on the spindle or the quill, and I want to be 83.5 below. So here I want the lowest reading. So I'll center it. Well, that is a problem. I might have to mill some off the bottom of this guy. I mean, fully bottomed out. It's still, it shouldn't be too hard to mill a little bit off that. Okay, back to you soon. Okay, milling this guy out. We'll see if we get a spark show. That was a 18 thou cut using carbide at about 700 RPM. Still in focus. Not usually as aggressive with cutting as I was with the sparks flying everywhere, but this was some kind of harden. Yeah, some kind of harden, and the inserts in that fly cutter were old, and it was just time to get on with things. Am I zeroing here? These guys are the right height. Grab a little Norbide stick. I always like to dress these points just to make sure that, I mean, A, for the cutting surface, the obvious point of dressing, but also for balance and concentricity of the stone. So we'll do that. Now I've got this set to cut really just at the end there, I've got it angled slightly like that. That's just so that I only have a little bit of the wheel cutting. I don't want the whole wheel cutting, because just, you know, it's not a very rigid setup with these little points, and it can create a bit of deflection. I pretty much got the whole end of that. Right. This is a temporary motor setup on this. I've got a much larger motor with VFD that I'm going to get installed, but this little console motor was sort of a quick and dirty setup. Something about like that. There. Full speed. Spend some time at this, making sure I've got a spark out. Might have been a better angle to have it out the whole time, but it's slightly more awkward for me to operate. But it looks like I'm getting a pretty nice finish in there. That finish looks pretty darn good to me. I want to put a slight chamfer on. This is really just to make sure that there's a sort of a protective chamfer on the hard chrome. It will stop it from getting caught and possibly flaking or peeling up, although I don't think that's much of a risk. It is supposed to be good form when you're working with hard chrome. Let's see how we've done. So there's the finished. Here's the finished piece. I'm very happy with the finish. I think we've got things perfectly concentric. And by using the sine bar, I hope I've got the angle dead on. I think I am at the point of being done as far as the quill goes anyways. This is, hopefully the indicator is in focus there. This is just to give a sense of the trueness of everything. If you can see the needle there, but I get, whoops, I just moved things there. I get 2/10 deviation on a revolution. I could have some deviation in the bore, I could have some deviation in the diameter. Tenths are hard to work with, and there's supposed to be some clearance between the quill and the diameter, so I have tried on this. I don't think that I can get it any better than the 2/10, and I'm going to declare it done at that. As far as parallelism goes, there at 2.6, and we're there at 2.6. Wow, look at that. I was confusing myself. So at least in that direction we're quite accurate. 2.6 there. and 2.6 there. Yeah, I can't get it any better than that, so I'm quite pleased with that. We're going to consider that done. The only thing I have left to do, it's scraped this way. I have to scrape it this way along this ledge here to bring it into alignment with the headstock. You can see it turns easily, but you know, if you hold that straight up and down, make sure I've got it in the image here. If you hold it straight up and down, you know, the quill doesn't fall out, so that's really right where I want it to be. The clamp is not on. That's just the fit that I wanted to see on this. So yeah, after a really protracted period of time working on this with, I'm calling this guy done.